This next demonstration has several names, and then we're going to focus on what it really is doing. It's known as elephant's toothpaste or giant's toothpaste because of how the foam comes out of the column and looks like someone's squeezing a tube of toothpaste. The actual chemical reaction is the decomposition of hydrogen peroxide. Everybody's pretty familiar with hydrogen peroxide. It's locally available in your drugstore at 3% ratio of peroxide, and very good for killing bacteria and dealing with cuts and stuff like that where you want to keep it clean from potential infection. It goes up from there, and 30% is what's used in this reaction here, and you can even go higher percentages in peroxide, and NASA and those that are using it in space use a higher percentage of peroxide and mix it with other things and form what we call hypergolic reactions, which instantly gives them thrust. Use it in thrusters and other things like that in spacecraft. What we're doing here is breaking it down. That happens in the space program as well, breaking it down. But what we're doing here is freeing the oxygen, and then because oxygen's not visible to us as a gas, it's colorless and odorless, we have to contain it some way so we can get a sense of how much oxygen is being freed up from this hydrogen peroxide. And that's why we have a soap solution in there. We've used different soap solutions over the years. Dawn works really well. We bought, and I think I've used it all up now, but we bought some lemon scented soap solution, and I always liked using that because it does heat up a little bit as it breaks the hydrogen peroxide down, and you get a little water vapor. You can see the vapor coming off the column because of the heat involved in the reaction, and that sends the lemon smell even more about in the room, and so you smell lemon after the demo's done, and I always kind of like that lemon smell that you would get when you had done the demonstration. What you have to do is get the peroxide to separate into hydrogen and oxygen, and so you end up as products of water, H2O, and O2, and the O2 is what we're capturing in that's the water, of course, is a liquid, so that's not going to change anything in the environment there of the reaction, but the oxygen is going to be freed up, and that's going to produce gas, and we trap that in the soap solution. Now, the key to getting the hydrogen peroxide to break down is you need to speed it up. It will, just sitting there, 30% in a beaker on the table, break down into water and oxygen very, very slowly. And so over time, if you're wanting to make sure a reaction's good using peroxide, you have to test it, because what you say is 6%, 3%, whatever percentage probably isn't, because it just naturally decays. So we're playing on that behavior and making it decay very rapidly so we get the oxygen produced quickly and we can see what volume that is. In order to make that work, potassium iodide is used as a catalyst. You could use it as a powder, but then the trouble is it catalyzes the surface of the hydrogen peroxide and doesn't get it all working at once. And so the idea is to get it a very good mix real quick so that it quickly converts to oxygen gas and you get a ton of bubbles coming out. What works well to do that then is to have the Ki in solution, and so have it as much as you can get a solution as a whole, actually a saturated solution of Ki. So when you dump that into the hydrogen peroxide, which also has some soap solution in there, the peroxide just very quickly breaks down and generates a ton of oxygen. The bubble solution captures that, and you get this column of bubbles flowing out of the column all over the table and into the sink or wherever you're at. It's a really neat aspect of demonstration, but very challenging to present, to take and have a wood splint when you dump in the peroxide or dump in the potassium iodide, to have a wood splint burning and being held there. As the foam comes out, putting out the splint, so it's not an open flame, but just a glowing ember of the wood there, and lightly touching the surface of the bubbles, which are very rich in oxygen, you actually can relight the splint. And if you do it carefully enough, you can do it multiple times. The challenge is, go too far into the bubbles, too much moisture, and you totally put the splint out. But if you can stay on the surface of that oxygen, which is a ton of oxygen coming out of the reaction, you can relight it multiple times. If you have the splint burning already and put it in there, all it does is enhance the flame. flame. It's more impressive to see it glowing but not burning, and then all of a sudden you've got open flame because the oxygen enriches the reaction. Again, a combustion reaction where we're dealing with a fuel, the oxygen, an oxidizer, and the reaction proceeding very easily because of those combinations together. Safety aspects of this one is 30% peroxide is fairly reactive, and so wearing gloves and being aware of that. It's not such that you do permanent damage to your skin in that, but if you've ever worked with that type of peroxide, it will decolorize the skin and work on the skin a little bit, but the skin repairs itself naturally and the discoloration goes away. But enough of it, you begin to feel the pain. It feels like someone's pinching your skin because the peroxide's working on the tissue there. So wearing gloves helps protect against that exposure. Cleanup then is not a real problem. The peroxide's all broken down. All you've got is oxygen and water left that's in there. The main thing to be considered there is the potassium iodide is still available, and iodine forms the yellow colorization, and that tends to stain things. So as long as you're careful about that and clean up, get it on a white shirt, you're going to have a yellow spot and probably not be able to get it out. But that's the main concern with that. It also is fascinating if you want to proceed with the reaction. We understand with catalysts, they participate, but they do not get used up. And so you can take that same solution with the catalyst you've added there and add it to another peroxide solution and see that it'll begin to react and break down too, because a catalyst is still being available to be used, which is the definition of a catalyst. Great demonstrations show the effect of the catalyst and how catalyst works, and also a vivid demonstration of a very simple decomposition reaction of hydrogen peroxide into oxygen and water. Safety-wise, the distance of people around there, people always want to come up and be around stuff or be right close, and this one you want to have them back so that the foam coming out there doesn't get on them. The main issue there is going to be that the iodine will stain clothing, it'll stain their skin and stuff like that. It's not necessarily a safety issue because literally the medical community use iodine solutions and rub it all over your tissue, and sometimes you got a huge yellow spot or orange spot on you because they're cleaning the surface before they do something that they're going to probe into the tissue. So it's not a problem that way, and it does naturally work, go away. But having them too close can get it on them, and that's not a good situation. And then there's also the tendency of people want to come up and touch it and do stuff like that. If they put a glove on, touching it's fine, but there again, if they touch the foam, the iodine's going to stain their hands and things like that. And it's just a good protocol to not let people touch things that are going to affect their tissue to where then they don't understand what's happened to them, what questions are going to be asked for that. Have you now been poisoned? Have you now got this on you? The reality is they haven't, but you want to prevent that so that it doesn't raise further questions. The higher the percentage of hydrogen peroxide, the better its shelf life tends to be. Once you begin to dilute it and add more water to it, it tends to break down, it seems faster, and not maintain its potency. So 30% probably isn't going to be 30% in a year, but it's still going to be a high enough percentage peroxide that it should work. But it won't work as good as a fresh bottle. It won't react quite as quick.